Good evening, everyone. Just a quick check. Am I audible?
Yes, Abdullah.
Okay, thank you. Let's wait for 2-3 minutes more. I think some more folks are joining, and then we'll start. Okay, guys, I think we can start now. So, yeah, good evening, everyone. Meeting after a week almost. So this is the third session, and we had last time stopped at the architecture of Snowflake. And there we had talked about how the compute resources and the storage resources are loosely coupled, or rather independent of each other, which is why scaling up or scaling down is flexible, and which also gives you uh, you know cost effective usage of your resources. And also you can have resources allocated as per the workload. Okay, so that was one of the major advantages of being independent of each other. So a little more deep dive on the architecture we'll be doing today. And yeah, I think, yeah, pretty much everybody's here. Okay. Okay. So as you can see, we call this layer as the storage layer. Okay. And it is in the cloud. And if, as you all know by now, that Snowflake can be hosted on 3 different cloud providers: AWS, Azure, and GCP. So considering that if it is hosted on AWS, So the service which Snowflake leverages for storage is S3 bucket, okay, which is what we had seen last time. We saw a use case of Netflix behind the scenes, what storage service it is using. So similar to that, Snowflake also uses S3 bucket as its service for storage. Then, okay, so request you guys to please go on mute. And if you have any questions, you can unmute yourself and ask your questions. Okay, so, and as far as the compute layer is concerned, it uses the EC2 service of AWS. Obviously, the services will change when the cloud providers will change. It is Azure virtual machines for the compute layer as far as Snowflake is concerned, and it is the blob storage of Azure. And for GCP, it is, I think, GCP bucket. I'm not too sure about the compute layer, what it uses. But yes, the services, but the architecture would remain the same. But obviously the services will change as the cloud provider changes. Okay, and as you can see, these are all heterogeneous workloads. Okay, so you have a loading workload, you have a marketing related workload, finance and dev and test. So each of these are independent of each other, these compute resources, and you can allocate them as per your workload, which is cost effective and also independent of each other. So the scaling up and scaling down is quite easy without any overheads. So as I said, storage is separated from compute. Okay. So, and it is a multi-compute cluster. So when we saw a few traditional architectures before, they were shared disk, shared storage, and single cluster. Then there was shared nothing, decentralized local storage, but still it was single cluster. But Snowflake came as multi-cluster. Okay, so we discussed what multi-cluster and cluster means. So not going into that now. And virtual warehouses concurrently access data without contention. Okay, so these compute layers, these all these compute layers, they are actually in Snowflake terms called as virtual warehouses. Okay, whenever you will see the documentation or even in interviews or I mean wherever, when you go to the web UI of Snowflake, which you will see soon, maybe today or tomorrow, and there you will see a term called virtual warehouse. So it is nothing but the your compute layer basically. So it is the clusters that you assign. So that is your virtual warehouse in terms of Snowflake. So here it is mentioned. So it says concurrently access data without contention. So basically, as this is a shared storage and it is a centralized storage, so when there is a concurrent access to it, there is no contention. Okay, because these are all independently accessing it, and obviously they're all meant for their respective datas. So marketing workload or marketing computing resource will obviously access marketing related data. Finance will access finance related data. So I won't say that it is 100% true that there won't be contention. There might be when they want to access each other's data, but yes, 90% of the time there won't be contention. And it says here what virtual warehouse, what is the service behind the scenes? It is EC2 for AWS, and Azure and GCP, it is virtual machines. Then for storage behind the scenes, it is S3 bucket for AWS, blob storage for Azure, and GCP bucket for Google. Okay. And the storage, whenever it is stored in the Snowflake, it is compressed, and the format of compressing and encrypting it is AES. I think AES 46, something like that. I'll confirm. We'll go to the Snowflake documentation and check. But whatever data comes here, it is always compressed and encrypted by Snowflake. Okay, so there is a standard format also. I'm forgetting the name for it, but we'll check. Then the storage is in virtually infinite scaling because this is all in the cloud, right? So all you have to do is ask for increasing and the cloud will provide for you. So basically behind the scenes, Snowflake will be provisioning the data storage for you, or whether it is compute also, it holds good for compute as well. And you have to pay only for stored data. So as long as you are storing the data in this storage area, you are going to pay to uh, Snowflake. Okay, you don't have to worry about whether it is on AWS or Azure or GCP. Okay, so there will be a rate card or a pricing, uh, you know, rules provided by Snowflake based on which you will be paying, and we will be looking at the pricing also in detail. Okay, so don't worry about it. We'll come to that, but you just need to know that you have to pay for only stored data. So what it means is, so sometimes there are temporary tables also and transient tables also that you create in the database. Okay, so those you don't have to pay for because they will automatically go once your session is over. Okay, so you don't have to pay for those kind of table data, only the ones that you are permanently storing. Okay, and since the compute and storage are separate, the payment is also separate. So whatever you consume in terms of compute, that will be separate pricing, and whatever you are doing as in the storage, that will be separate pricing. Okay, so
Yeah,
guys,
Abdullah, one question.
yeah,
Sorry to interrupt. Yeah. So when you say the data that we are going to store is getting the amount that is getting the amount of which that we store it. So we can classify data into two, right? Hot and cold data, right?
yeah.
So before storing itself, we have to classify and then store, or based on the data that we store, it is actually in the Snowflake itself comes to this analysis and then gets the payment, or how is it?
So by hot and cold, what do you mean? Cold, do you mean temporary data?
Yeah, cold means if some in some of the systems, right? So master data might not be used even again. So only transactional data will be used in some of the applications. So
Mhm.
whenever it is an analytical output we are taking, or whenever we look for some reporting side, then we integrate this both master data as well as transactional data, right? So in
Yes.
that case, so we need to classify before we store it, so that we can save some of the amount for when for storing, or is it the Snowflake itself identifies and then we have to pay for only those hot data? My
Okay,
question is that
so
actually.
there is no concept of hot and cold. Whatever has been stored here permanently, whether it is your dimension table, which is normally your master data, and your
Mhm.
transactions, there'll be a fact table for that, right? So
Yeah.
those you have to pay for as long as they are in this storage on
Okay, got it.
in the permanent tables. There are three
Okay.
kind of tables in Snowflake: temporary, transient, and permanent, which we will look into detail. But
Okay.
by the word, you can understand that permanent will be permanent storage only. So for that, you
Okay.
have to pay, whether it is the dimension data or whether it is the fact data.
Okay. Okay. Clear.
Okay.
Thank you. Yeah. Thank you.
And
Abdul, one
pricing,
question.
yeah.
Let us assume 100 GB is being assigned for my project, but so far I have consumed data stored only like 50 GB. So should I pay only for that 50 GB what I have stored the data, or the 100 GB assigned for my project? So how should
Yes.
I pay for that?
Yes. So as I said, there is a pricing model which Snowflake has. So there is on demand and there is pre-purchase plan. Okay. So when I come to that, this will answer your question. Okay. But for as of now, you can say that you have two types of payments which Snowflake offers as far as the storage is concerned. It is pre-purchase. By pre-purchase, obviously, it means you are going to pay upfront for a certain amount of storage. And on demand means as and when your data comes, that pricing will be applicable. So there are two kinds of pricing. So, but those details I'll tell you once I come to that Snowflake pricing topic.
Okay, okay.
But to answer your question, there are only two types: on demand and pre-purchase. So rates and all I will tell you once I come to that. We'll go to the Snowflake.
Abdullah,
Yeah.
I have one question here.
Yeah.
In virtual layer, there are multiple warehouses, right? When these in virtual layer, the generally calculation computing will happen. When these virtual layer, these different warehouses try to access same data, there won't be any locking kind of concept in here in
No, 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 no.
Snowflake architecture.
No, no, no. So all the asset properties of any normal database, right? Whether it is locking or anything. So all that asset properties will be applicable to this. But what is trying to say is, of course, if say marketing data is updating something on a marketing table or sales table, say sales fact, and
Yeah,
finance is trying to also update the same rows. So that will
yeah,
obviously give a contention that, and that will obviously lock it because it follows all the norms of the asset properties. Okay,
okay,
atomicity, concurrency, integrity, and all that
yeah,
transactions.
hmm,
Okay, so that is there.
okay,
That won't change. But what it means to say here is that when the warehouses you create for different purposes. So for example, this is a loading warehouse here, ELT operation. This is simply going to keep dumping the data. It will never do a select on some data, or it will never, maybe what? It will insert and update. It will never delete and it will never select. Okay. So
okay,
this marketing and finance guys, they will be mostly into reporting. Okay. So they will be
yeah,
mostly doing selects. Okay,
yeah,
so that way you will not have contentions because you are basically segregating the type of tasks. Okay, so that is what it means. There will be no contention. But as far as, so what happens is basically when you update something in Snowflake, suppose consider that this ELT process is going on, okay, and you're updating a table. So it doesn't wait or ask for you to commit or roll back. By default, it commits itself unless you do something special. So I will not tell you right now, but I'll tell you later. But by default, it commits everything. So which is why on the next session, if somebody is trying to update that row as well, so that contention is not there. Okay. Because by default,
okay,
it is immediately committed, right? So once it is immediately committed, so other person who's trying to update it after that, that warehouse will also be able to update it. So that I will show you. But if you want to lock it, there is a special way to do it that I will show you. I mean, once we come to the
okay.
UI and all.
Even in reporting also, when a marketing warehouse and finance warehouse, or when they are trying to report on the same tables, there can't be any chances for getting blocked.
No, because
Tables will be
whenever
blocked.
you do a select, there will never be a locking. It is locking is always based on delete and updates.
Insertion updation, but agree.
Not even insertions. So for insertions, you will not be locking. What will you lock? It's a completely new row, right?
Okay, okay.
Okay, guys.
Thanks, Abdullah.
Yeah, no worries. So now always remember that Snowflake architecture has 3 layers. They have divided into 3 layers. Okay. So the bottommost layer is the storage. Okay. Above that is the compute layer, which is also called as virtual warehouses. These are all individual virtual warehouses. Okay. It's not one virtual warehouse. It's independent other virtual warehouses. And this is also called as muscle layer of the Snowflake architecture because it is doing all the heavy processing. Okay. And all the query processing stuff this layer is doing. So that is why it is called as muscle of the Snowflake architecture. So sometimes in the certification exams, they ask you like how many layers are there, and then they will give you some layer names and say which are all the applicable layer names. So storage layer is there, then there is a compute layer. This is called as compute layer also. This is called as query processing layer also. And this is called as a muscle of the Snowflake architecture also. Okay. And then on topmost is the third layer, which is called as cloud service layer. This one. So this is the service layer, or you can call it cloud service layer also. And this is the brain of the architecture. They call it the brain. So what it does is basically, so it is managing all the interaction between compute layer and the storage layer. So whenever the query comes in, to generate the optimization plan, to check the authentication, to compile the query, to check the metadata, that all is done in the compute layer. So whether the query which has come, whether do you want to take it directly from cache, is that result of the query present in cache? So if it is there, let me immediately give it back. I don't have to go to compute layer and recompute it. So all that kind of stuff cloud services do. So optimization, as I said, the management also, and transactions. So that locking mechanism and maintaining the the consistency of the transaction. Then the security. So basically, when you log in also to the Snowflake, the authorizations and all that is also done by compute layer, and the metadata is also managed at the compute level service. So this whole thing, this particular topmost layer is called as service layer or cloud service layer, and it is also called as the brain of the Snowflake architecture. Okay, so this is the third layer. So as you can see, this is a centralized management. It is doing a centralized management, and metadata is separate from storage and compute. It has full transactional consistency across the entire system. So this layer is maintaining that. Earlier, what used to happen in your shared, nothing, each and every node had to know about it. If one node updated it in the shared one, sorry, in the shared disk single cluster, if one node updated the common storage area, all the other nodes needed to have that information. But here, the metadata is managed at the cloud service layer. So it is going to manage this. Then authentication and authorization. So once you log in, so there are different ways of authorizing, right? So there is multi-factor authentication, then there's a password authentication. So that all authentication is done by the cloud service layer. Then to manage, so whenever you log in, a session is created for you. So that is called as your user session management. Then, as I said, query compilation, optimization, and caching is also managed there. Then the virtual warehouse management, so that when you ask for scaling up and scaling down for a particular warehouse, say you want to resize a warehouse or you want to scale up a warehouse while the query is running. So that management is also done by the cloud service layer. And the entire query lifecycle from submission of the query right till in between of execution, right till the end of showing results to you. That management of the life cycle is done by the cloud service area. So here in the compute layer, it is basically doing the query processing only and allocating resources as per the query intensity, how much provisioning of compute resources are required. That plus query processing. This is simply the storage area, and all the management work is basically being done by the cloud service layer. So always remember there are three layers when you talk about Snowflake architecture. Yeah. So this is a deeper look. As you can see, as I told you earlier, that each this whole cluster, this is called as virtual warehouse. Okay, so it basically, what is a virtual warehouse? It is nothing but a combination of nodes, right? And what a node will have is your RAM, your processors and codes, and your its own memory, cache memory, its own hard disk. So it is basically nothing but EC2 machines, combination of EC2 machines. And as you can see, the whole database storage layer is shared by all the virtual warehouses. And you can have multiple virtual warehouses as per your needs. And on the top of this, you have the cloud service layer. And it is showing its various actions that it can do. And on top of that, you can connect to Snowflake with external connectors also. So with Java, if you want to connect with Java, then there is JDBC, ODBC, and there's Python connector also. So you can, if you want to leverage some, say, if else and looping kind of, methodologies provided by these languages, then you can connect, say, for example, Python, there will be a connector for Python. You can establish connection with Snowflake, okay? Like how you normally do with Oracle or any other database. That way you can establish connection with Snowflake, and then you can fire Snowflake queries through that and do your ETL work or maybe testing work or do whatever is required. So as you can see, storage is decoupled from compute. So okay, I've been saying loosely coupled some time back. So that's not right way to say it. Okay. So pardon me for that. We should not call it loosely coupled. We'll have to call it decoupled, because this is completely independent. Okay, loosely coupled are not completely independent, right? So let's call it decoupled. Storage decoupled from compute, and all data is in one place. Okay, and they dynamically combine storage and compute when they have to do the processing. So this is an overall architecture view of Snowflake. Okay, cool. So how it is working under the hood, basically, it is the Amazon EC2 which forms the Snowflake virtual warehouses. Okay, and as per the nomenclature of virtual warehouses, they come in various sizes, predefined sizes basically, and you have to select from them. So the smallest one is extra X small. Okay, it comes as a single node. Okay, that means if you choose your warehouse of X small size, you will be provided just one node for that. And similarly, there is small, medium, large, and X large, and respectively they have 2 nodes, 4 nodes, 8 nodes, and 16 nodes. And as you can say, it's a factor of 2. Okay, 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. That's how it goes on. On the web UI, when we create a virtual warehouse, we will have a look in detail of this. But on a overall high level, these are the various sizes virtual warehouses come in. Okay, so for example, if you're doing some DDL work, you can have an extra small size. If there's a data load, then you can have a medium one, which is of 4 nodes. Okay, so that way, this is how it works under the hood as far as virtual warehouses are concerned. So if you are hosting it on Amazon with AWS, it will be Amazon EC2 service. Then there is Snowflake architecture. And there is this database tables. They are basically S3 files. Okay, so when you store the data in the database for Snowflake, their actual location is S3 files. Okay, even in Oracle or any other database, there is nothing called as a table. I mean, if you want to look it from a physical perspective, right? There's nothing called as a table, right? Everything is stored on a disk. Okay, and logically, when you see it on the screen, it shows you in the form of a table actually. So the logical structure is a table. So on the front end of Snowflake, you will be seeing or viewing data in the form of tables, rows and columns. Although they are not stored as rows and columns, they are in columnar format. Okay, and actual will be the files, which will be on S3. So it's an interesting, selection which Snowflake made, that why they went for S3, because S3 has some challenges, because there is a IO latency, okay, and which makes it a bit slow. And obviously, when it is IO intensive, there will be a lot of CPU overhead, and there is object storage, which means that it is overwrite only. You cannot update a data. Okay, if you want to update, you will have to overwrite the whole stuff. So these are the challenges with S3. But why they went for it is because it has a high availability. So Amazon says we will be giving 99.99% availability as far as S3 storage is concerned. So if you keep your data in S3, we will make sure that it is available 99.9%. And how that happens is, I mean, as a Snowflake developer, it is not our concern, because it's all about cloud, so they have those availability zones and, CDNs and all that. So that is not in the scope of Snowflake, but behind the scenes, they have a lot of replication in the form of availability zones and all that, just for your knowledge. And durability. So there is very minimum and low chance that your data will be lost. Okay, I mean, ideally there is no chance, but but nobody will say that we are 100% secure. Nobody will ever tell you that. So the durability is maximum, and the biggest advantage is you can read data in parts, which means if you have a file of say maybe 1 million rows, so if you want to read a particular range, you can directly access that. You don't have to read it sequentially. You can directly go to that partition and read that particular data. So which makes it really faster. Okay. And how data is structured in Snowflake, that there is a separate topic called micro partitioning and columnar format in detail. So that we will be looking anyway. Okay. But these are the advantages of S3, which is your highly availability, then there is durability, and you can read the data in parts. Okay. Cool. So the Snowflake storage layer, so it basically stores all data in databases, okay, which is nothing but a logical grouping of your different objects. And what are those different objects? Obviously, these are all logical objects, tables, views, then UDFs means your user-defined functions. There is something called as stages also. So this stages is also a separate topic, basically, which will be used to load data and unload data. So loading data into Snowflake from various sources and unloading data from Snowflake to other sources. That is what stages utilization will be. And that is a separate topic. Okay, so we'll be looking at that in detail. And one more important highlight is that it takes both semi-structured and structured data. So it can store both. And for the easiness, what it does is, for example, there are structured data, right? So there's those standard SQL data types, right? Integer, number, varchar2, varchar, char, those type of data types are used. As a database person, you must have come across all these data types. For the semi-structured, so these formats, right? These file formats, these are all your file formats: JSON, Parquet, ORCL, XML, Avro. These file formats, they directly go and get dumped in a data type called variant. Okay, so there's no separate data type for JSON or Parquet or ORCL, nothing like that. For example, in Oracle, they have come with a data type called JSON. So you can store a JSON data in that kind of a column. But here it is not separate for each format. There is simply one data type called variant, and in that you can store any kind of semi-structured data. You can store structured data also, because it won't identify whether it is structured or unstructured. But ideally, to maintain the hygiene, if you know it is structured, obviously you will keep it in something which is a known data type. But when it is semi-structured, then you will keep it in a variant data type. Okay, so all these kind of data can be stored and processed. Then, as I said, as soon as the data is loaded, Snowflake compresses it in an optimized columnar format. Okay, so we'll see what a columnar format is. So Oracle basically stores your data in row format. Okay, even when it is storing on the hard disk, it is storing in the row format basically. But when Snowflake is storing it, it is storing it in partitions, which is called as micro partitions, and they're all column based. Okay, for example, you have an employee table. So employee name, employee ID, salary and all that. So that employee name column, that data will be stored separately. Then your employee IDs column, all those IDs in that coming within that column will be stored separately. And those will also be stored in separate partitions. So that is why we call it as columnar format. So for any OL TP kind of a data warehouse, which is why NoSQL databases became quite famous, because in analytical reporting, such kind of columnar format comes very handy and it is very fast. Okay, because most of the time the reporting is column based, and you don't fetch all the data, right? So that is why NoSQL databases were more preferred. So Snowflake you cannot call it exactly relational database or data warehouse, but it leverages. So it has basically leveraged all the positive stuff of the various technologies. So from shared to shared nothing, it took some advantages. From databases, it took some advantages of columnar format and all that stuff. So that is what it has done. And once the data is there, it gets compressed.
Abdul,
Yeah.
sorry for the break. Even Oracle also uses a compression technique called HCC, hyper columnar compression method. So they also store it in a compression way. They also store it in the partitions. But I couldn't exactly figure out how exactly the Snowflake differs from HCC columnar architecture of Exadata storage structures.
Okay, so I was saying that Oracle stores data in the row format and Snowflake stores it as columnar format. So there is a difference there. Okay, so compression, today every database does compression. So that is not a difference. Okay, so it basically is about the way it is storing the data. So as I said, it is columnar format in case of Snowflake, and it is row based as far as Oracle is concerned, which is why it is not preferred mostly for analytical purposes. It is only mostly for OLTP purposes and not OLAP. And you also said something else. What was your question on the other part?
No,
Partition. You said partition. Okay,
yeah.
so yeah, so Oracle doesn't do partitions by itself. You have to mention the partitions when you create tables, correct?
Yeah, we have to enable the partition. By default,
Right.
It doesn't use partitions.
Exactly. So by default, Snowflake does partitions.
Oh, okay. Okay, got it. Yeah.
Okay.
And
so
Abdullah, one information for your information, SAP HANA is also columnar storage.
Yeah. So MongoDB, so most of the NoSQL kind of databases, right? They're all columnar formats. So it has basically leveraged. So columnar format is quite fast when it comes to OLAP kind of stuff, right? So when you're doing analytical reporting, so there it is very fast. So I'm not saying that row based is not fast. Every structure has its own advantages and suitability for a certain type of workload. So since it is a data warehouse and it is mostly considered for analytical processing, it chose for columnar format. Okay, and it is by default partition, which is we have a separate topic called micro partitioning, and you can also do customized partitioning on it. So that we will see in detail. So just on a high level, I'm telling you right now how the storage looks like. Okay, and as I said, it is encrypted, and I was forgetting the method, right? So it is AES 256 method. So they in the architecture, in the certification, sometimes they ask like, what is the encryption method used? So you can simply remember AES 256. Okay, next. Yeah, so this is your virtual warehouses, which is the compute layer and also called the muscle of the system. It is where all your queries are executed. Okay, and compute machine needs to be provisioned before your query execution. So basically, these machines, they will be started only when you're executing your query. Okay, so which is why it is cost effective. They will not, once you have assigned a virtual warehouse or created a virtual warehouse, immediately the billing doesn't start for you unless and until it is being used for certain query processing or query execution, similar to the cloud way of pricing. Okay, pay as you use. Then virtual warehouse can be chosen and configured as per the query load. So obviously, it depends on the kind of query you want, processing you want to do. If you're doing a ELT processing, you can have a separate virtual warehouse created for it. If there's some finance team which wants to do some stuff, it can have a separate virtual warehouse for itself, and so on. So that's what it means. So Snowflake handles the underlying provisioning and configuration of the virtual warehouse. So you don't have to worry about provisioning. All you have to do is configure, and Snowflake will take care of it. And the best part is it can be scaled up and down at any time, and it can be resized also at any time. Okay. And concurrency management is also done by Snowflake. So when I say, for example, this warehouse is doing some query processing and it has got some concurrent queries coming to it and they're getting queued, So all that management is also done by Snowflake. So you don't have to worry about it. So just want to explain one thing here when it says scale up and resize. So I want to just explain the difference of that, because this is also asked in the certification. Okay, so consider this is your this is your storage. Okay, and say this is your warehouse of say extra small, not extra small, small. So this has 2 nodes. Okay, this is your one virtual warehouse. So this whole thing is your one virtual warehouse, and it is nothing but extra small, nothing but 2 node cluster. Okay, and you can have it as multi-cluster also, which means you can say, okay, I want this type of cluster in number of 2s. So this whole thing will be, so for example, I will, when I will am creating a virtual warehouse, I will say I need a 2, my cluster should be 2. So this is my 2 node clusters. Okay, so these are my 2 nodes cluster, and this whole thing is called as virtual warehouse, not just one. Okay, if you say one cluster, only one cluster is required, then that will be virtual warehouse. But if you are saying I need 2 clusters of extra small, if you say, okay, I need 2 clusters of extra small, I'm sorry, not extra small, small. This should be small, because extra small is just one node, right? God, I'm so bad with this paint. So this is your 2 small 2 node cluster. And this is a multi-cluster because you have 2 clusters here. This is one cluster C1, this is one cluster, the other cluster C2, and this whole thing is nothing but this whole thing is your virtual warehouse. So the important thing to understand here is when it says to scale up, so it means to say that increase the cluster. Okay, so it will say scale up and say I want 2 more clusters. So it will scale up 2 more clusters like this. Okay, so 2 more will come, and the small size, it's a small size, so it will contain 2 nodes. That is called as scale up. And when it says resize, so within the cluster, it will say, it will basically say resize. So this is what is small, it is a size, right? Small is size. So when we say resize, so that we are trying to say, okay, modify this size. Okay, so it could be you can resize it down way, and you can resize it in the increasing way. So if you say you want to go from X small to medium, so its medium is, as we know, is 4 node, right? So it will add 2 more nodes here. If we say resize it to medium, that's what it will do for the whole virtual warehouse. Okay, so this is called as resize. But if you say, okay, I want to scale up, so you will not be changing the size. You will be simply adding 2 more clusters. I mean, if you want to scale up by 2 clusters, you will be saying 2 more clusters. So these 2 will come. These 2 extra clusters will come. So that is called a scale up. So scale up means increasing the clusters, and resize means increasing the compute resources size. Okay, and similarly you can scale down also. So if you scale down and you want to say, okay, I have 4 clusters, I want to scale down to 2, so the other 2 will go off. And say if you want to resize down, you are currently, this is your medium, and you want to say I want to go back to small, so you can remove 2 nodes from here. So this management will be done by Snowflake itself. Okay, you don't have to worry about it. You just have to say resize it or scale up. That's all you have to say. But that is the difference which I wanted to clarify, because it is asked in interviews as well, and it is asked in certifications as well.
Abdul, sorry for interruption.
Yeah.
See, in the previous slide, you were showing that we have to select the size of the EC2 instance, small, extra small. I think that is a correlation of EC2 instance size, right? Instant types or yeah, this sheet. You are mentioning to choose which EC2 instance you want, right?
Yeah.
Right. So here itself we say what kind of nodes and what you want here when we provision the Snowflake. But when you go there on the again you are explaining we can scale up or scale down and all, right? Is this both the steps same, or even we can change our EC2 instance type based on the demand later, or how? I see some um, contradictory concept here, Abdul.
Okay. So EC2 instant type, we don't have any control. What kind of EC2 core and what are the configurations when you do while EC2. When you see the web UI, right, you will be more clear what it means. So by the type of EC2, that Snowflake will take care of it behind the scenes. This is when you go to Snowflake, this is the option that you get. So if you say X small, it means it will be providing you one node for your computing resource. One node means one machine, one computer. Okay, small means two computers, medium means four computers. So you have to, when you are configuring your virtual warehouse, or rather you're creating a virtual warehouse, you have to choose first a size depending on your workload. Okay, now you are asking scale up and scale down, correct? What is that?
So
Right.
on demand. For example, when Snowflake decides the existing resources, computing resources is not sufficient, right? So when automatically Snowflake decide to scale up or scale down, or is it something manual intervention? We have to check, okay, Snowflake is unable to process this much long query, we have to increase. Is it something manual intervention that we need to do, or how it will automatically take care of scale up or scaling down mechanism, Abdul?
Yeah. So let's consider this diagram. Let's say you have chosen, this is medium size. Okay, don't go on this. Let me remove it. So, okay, suppose you are creating a warehouse and you choose medium size. Your medium size is 4 nodes. Okay, in that, so obviously when you say 4 nodes, I told you that it comes in the form of cluster. So this is 4 nodes cluster, this single one. Okay, so in when you're configuring or creating a virtual warehouse, it asks you how many clusters also you want. Okay, that also it asks you. So you say, I want 2 clusters of this size. Right? So you created 2 clusters here. Okay. Now, when your query load comes, accordingly, it starts the clusters. So for example, this second cluster is not required to be started. It will not start it, because if your first cluster is capable enough to take the query load, whatever is incoming to it, it will keep on using it. Once this is fully loaded, and then there is a queuing of queries to start, which starts up, it will spin up the other cluster automatically. You don't have to worry about it. Okay. Now, suppose now 2 clusters also have been started. Whatever you have configured, that will be automatically started as per the need. Whatever query is coming, if it's able to handle the load, it will spin up and spin down accordingly. Now, suppose queries keep coming, and I mean, these are not able to take the load. So your question is whether it will do. So you need additional clusters here, right? Same size.
Yeah,
Additional.
but yeah,
So
For example, my query need additional clusters, but the instance type what I have chosen earlier, right? That is limiting. For example, I have chosen only small,
medium.
right? Yeah, or medium, right?
Yeah.
So in this case, so all the here based on you mean to say this selection will limit our processing capacity, right?
Yes. So that's what I'm saying. So you have chosen medium cluster, okay, 4 nodes, and you have also chosen that you want 2 clusters. Till here it is fine.
Yeah.
Okay. Now you're saying this is also not capable of handling whatever is incoming queries
Yeah.
to be processed.
Yeah.
So in that case, there are 2 ways. Either you can resize. Resize means change the size here. These are your sizes. Okay. So from so that you have to do manually, of course, because you have while creating the warehouse, you have set some size on that time. This size you have set for medium size. But suppose you want to resize it, so all you have to go and do is change the size to large. So Snowflake will start provisioning 4 to 8. So Snowflake will add more 4 nodes here in these clusters. Okay. So that you have to do manually. I mean, you don't have to go and provision it manually. You have to tell Snowflake, make it large from medium to large, do that. Snowflake will provision that for you. Okay. And the other part or aspect is that if you want to add more clusters, so this which I told you that you want to go from medium to large is called as resizing. But suppose if you have chosen in the beginning 2 clusters, you want 2 clusters, but then you say, no, I want more 2 clusters, and then Snowflake will add 2 more clusters but you have to tell Snowflake, add 2 more clusters. So behind the scenes, it will come and add 2 more of this same, if you're keeping the same size, it will add these 2 clusters, extra 2 clusters, it will be totally 4. That is called as scaling up. Okay. And once your workload is done and you don't want to keep that same size and you want to go back to original, you can go back and tell Snowflake, okay, from 4 clusters, make it back to 2. And from 8 size, which is your large size, make it back to medium. So it will remove the 2 clusters and it will reduce the size also. But how it is doing behind the scenes, that you don't have to worry. That all is done by Snowflake itself. You just have to tell it, resize it to this size or scale it up to this many clusters. That's all you have to say to the Snowflake.
Okay. Which means that, some manual intervention is required when the job goes to production and profile it based on the resource usage.
Yes. So basically, you have to first do trial and error of what is the exact size you want to make for a particular workload. Okay. All those strategies we'll be discussing later. But since we're talking about architecture, so we are going on a bit high level here. So yes, but you have to do experiment with various virtual warehouse sizes and accordingly come to one conclusion. But suppose your estimation was not correct, and on production, it so happened that it is getting slower. So you can just go and tell Snowflake, and you can say you just have to reconfigure it. So it is basically, in terms of databases, you will call it alter. You have to alter the warehouse. So there is this alter command, right? Alter table, add column, modify column, and all that. So similarly, this warehouse is also an object in Snowflake. So all you have to do is alter the warehouse size or alter the warehouse cluster size. That's all you have to do.
Yeah.
And
okay.
yeah.
Got it. Yeah.
Abdul,
Is there, Abdul? Sorry. Is there any way, Abdul? For example, this scale up or resizing, right? It happens only in particular time frame. For example, my scheduled job. I have some jobs that only between 5 to 7.
Sorry, I can't hear you guys. Am I audible? Can somebody confirm? Am I audible? Vinod, am I audible?